Hello. Good evening, everyone. Welcome, sir, to the fourth day of FTP, Sustainable Manufacturing and Advanced Automation in Industries. Now, I would like to request one of our faculty from Mechanical Department, Mrs. Krishna Susi Sangita Sahu, ma'am, to introduce the speaker. Ma'am, please.
Good evening, everyone. Welcome, sir. It's a great honor to welcome you all to this enlightening session on product development, intellectual property rights, and destructive and non-destructive testing of mining and allied equipment. Today, we have the privilege of hearing from a distinguished expert whose extensive experience and research contribution have significantly advanced this field. We are pleased to introduce Dr. Sudhir Kumar Kashyap, Senior Principal Scientist and Head of the Section at Roof Support Testing Laboratory, CSIR, Central Institute of Mining and Fuel Research, Dhanbad. With an expressive 34 years of experience, Dr. Kashyap has been at the forefront of product innovation, safety testing, and mining equipment development. Dr. Kashyap earned his PhD from NIT Rourkela in 2012. His expertise lies in stress analysis, flame-proof enclosure, and structural integrity assessment, with a strong focus on ensuring safety and efficiency in mining and allied industries. As a senior principal scientist at CSIR-CIMFR, Dr. Kashyap leads cutting-edge research and testing related to roof support system, mining safety protocols, and structural durability assessments. His work has been instrumental in developing innovative testing methods that ensure structural reliability and operational safety in harsh mining environment. With a distinguished career spanning over 3 decades, Dr. Kashyap continues to shape the future of mining technology, product safety, and industrial testing methodologies. His invaluable insights and vast experience make him a guiding force in the field. We are truly privileged to have him with us today. Without further any delay, please join me in welcoming Dr. Sudhir Kumar Kashyap, sir. Sir, please.
Hello. Welcome to the session, sir. Yes, sir. You have saved the screen. Hello. Am I audible?
Hello. Hello.
Yes, sir.
Hello. I'm audible.
Yes, sir. You are audible.
Okay. Okay. Good afternoon to everybody. Thanks to the faculty member, teachers, the students, and our good friends and ladies and gentlemen who have given me the opportunity to give a lecture, keynote lecture on this FDP program. My today's topic is that I have selected mind to manufacturing in automated domain. Actually, the topic which have been given to me was a little bit complicated to me, but anyhow, I have summarized all the topics that parameter and prepared the slides. I'm audible now? Audible? Hello? Hello?
Hello. Yes, sir.
I'm audible? Huh?
Yes, sir. Yes, sir. You are audible.
Okay. Then my today topic is mind to manufacturing in automated domain. You have given the that means topics for today lectures, that was sustainable manufacturing and advanced automated in industries. So on that topics we have prepared small slides on the mind to manufacturing in automated domain. So that is, manufacturing is nothing but it's a new technique, and anything we have, the human being is using any utensils or any things, any worldly things which has been manufactured anywhere, whether it is glass, wood, or any cement manufacturing or any manufacturing. So first of all, it came to our mind what to manufacture and what product has to be developed. So in that way, we have prepared these topics and we will slides. So I was working today. I'm superannuated as a chief scientist of CSIR-Central Dhanbad 1 year back. Previously, I was working in CSIR, Central Institute of Mining and Fuel Research, Dhanbad. And you must be knowing CSIR-Central Dhanbad is a very much important laboratory in the world. No such laboratory existing in the world on which work on mining technology, mining product development, and mining efficiency, underground mines, coal mines, and open cast mine. So the milestone of this Central Institute of Mining and Fuel Research, Dhanbad, is Central Fuel Research Institute in 1946. It was established, and then Central Mine Research Institute was established in 1956. And these two institutes have been merged in 2007, and now the name of Central Institute of Mining and Fuel Research, Dhanbad. The core sector, core R&D sector of this institute is coal and non-coal mines and civil sector, fuel sector, environmental management, testing analysis, and conservation services. And a part of this, other R&D work we are doing, like there are national facility for FLP, flame-proof testing laboratory, intrinsic safety, explosive and mining safety equipment testing facility for coal and rock properties, environmental parameter, coal processing, monitoring of underground mines, geomining conditions, high temperature pressure, single tube fixed bed reactor, pilot plant for coal processing, high performance computing for large scale geomining modeling and simulation, scanning electron microscope, and coal to liquid plants. Now this is our institute building, the front side of the institute building where I was working, Central Institute of Mining and Fuel Research, Dhanbad. So in our topics, we have written the mind. What is mind? You must be knowing what is mind. The mind is a set of faculties. Everywhere in institute also, we always talk about the faculty of mechanical engineering, faculty of electrical engineering, faculty of other department also. The mind is nothing but a set of faculties. A set of faculties means including cognitive aspects such as consciousness, imagination, perceptions, thinking, intelligence, judgment, language, and memory, as well as non-cognitive aspects such as emotions and instinct. That means in a mind is a set of faculties where there are a number of such departments, like in your department, electrical, mechanical, civil, mining, computer science, like this. So there are consciousness department, imagination department, perception department, thinking department, all departments are living together as a faculty member in a mind. That is called mind. Then what is manufacturing? You must be knowing what is manufacturing. Manufacturing refers to a large scale production of goods that convert raw material, parts and components into finished marketable product using man and machine, and now with automation. That means manufacturing of any product or anything we are going to manufacture, we require large scale production for human being needs, production of goods, and that convert. Manufacturing is nothing but it's convert raw material. Raw material maybe anything like raw pig iron, raw woods, raw cement, raw sand, raw clay, anything it can be. Raw material, and that this raw material can be converted into finished product, the finished product by which we use this, a human being uses this finished product, or it may be parts or component of any finished product. This is called manufacturing. So automations, we are talking about automation in manufacturing. Basically, automation based on three things. That is digitization, digitalization, and digital transformation. So automation is nothing but depending upon these three parameters, and these three parameters have different meaning. Digitalization, and digital transformation have different meaning. The three are not the same. So what is digitization? Digitalization, and digital transformation. The definition is digitalization is nothing but is the conversion of analog system to a digital system. Digitalization is nothing but it is the conversion of analog system like mechanical system into a digital system. Digitalization refers to the internal optimization of process, e.g. work automation, paper minimization, computerization of machine, digitization of measuring and other instruments, email, local area network, LAN, etc., which result in cost reduction. And what is digitalization? There is difference between digitization and digitalization. Digitalization is the use of digital technology and digitized data. In digitalization, we use the data only compared to digitization to impact how work gets done, transform how customers and companies engage and interact, and create new digital revenue streams. It is for changing the entire business model. Now come to the digital transformation. Digital transformation is very easy to understand. Digital transformation is more about people than it is about digital technology. Like we talk about now today, our Prime Minister is saying Digital India. Digital India is nothing but digital transformation. Digital transformation means digitally we transform the data, or digitally we transform the things from one person to another. All employees are required to be trained digitally. Digital transformation requires a much broader adoption of digital technology and cultural changes, like our mobile phone. Now, organizing for managing innovation for manufacturing. Before manufacturing, we go for innovations or any invention, because first of all we have some conceptual idea, we should have some mind, then creativity, and then we go for the manufacturing. So before going for manufacturing, we go for innovation. So for innovation, we have the managing the people. Like there are 4 people here, 4 people here, 3 people. First of all, we manage the people who are going to manufacture the product. So introduction that we can say the Albert Einstein, the great scientist, he has told that the history of scientific and technical discovery teaches us the human race is poor in independent and creative imagination. Even when the external and scientific requirement for the birth of an idea having long been there, it generally needs an external stimulus to make it actually happen. Man has to speak, to stimulate right to against the things before the idea comes. This statement was given by Albert Einstein, who is a great scientist. There are a total human population of 7 billion in the world, even more than that. In his globalization era, every country in the world is struggling to provide easier life. Easier life is only possible by the newer manufacturing technology or newer product. There is science and technology which opens an opportunity and create technology and product that makes our life simple and easier. As creativity comes first into the mind by observing the local problem. When we see the local problem, the creativity immediately comes to our minds to manufacture something. It is said that think globally, act locally. That means before going for any new idea locally, we would have to think in open perspective of the said problem. We talk about new things, creativity, invention, discovery, innovation, etc. We often forget the minor difference among these. There are a number of parameters like this: creativity, invention, discovery, innovation. We often forget the minor difference. There are differences between these 4, 5 parameters. We'll go ahead and to make you understand. To achieve the industrial growth of an enterprise, there is a long journey to be completed. After completing the critical journey, the expected economic growth of any organization by manufacturing would be assured, which is all needed to any developing nation in the line of industrial revolutions. So we will go for a conceptualization first. What is conceptualization? Before manufacturing, we go for concept. We should have concept. What item, what product we are going to manufacture in any industries or any factory. The human mind has a prodigious capacity for representing the things. The mind is having no limitations to things. Instead, we can think about various things that are far away in space or time. We can even think about things that never will exist in the real world. We always think about the things which is not existing in the real world. So in manufacturing, there are 3 things: input, conversion, and output. What is the input? We give the input as a raw material, and we convert it by the various machines, automated machines, and then we got the output as a product, as a finished product. So here you see there is a material, and either manufacture. Here is the manufacturing machine, or here the manufacture, the material, and we give the knowledge also. This is a conceptual knowledge or creativity. We give the materials into the manufacture and knowledge. Knowledge means we go for the R&D, and we go for the design, then we go for the manufacture. Before manufacture, we have to do the homework for this R&D and design, then we go for the manufacture, and finally we get the product, finished product. So one of the central question is that how we are able to represent the world to observe in thoughts. So in thoughts, what we are giving to the world as a manufactured product or finished product. That is why we can say that our capacity for thought to grounded in our conceptual ability. Thoughts are seen as having constituent or parts, namely concept. In fact, the theory of concept has become a key point for demarcating vastly different approaches in the mind. Thoughts without content are empty. Immanuel Kant has said that thoughts without content are empty, and intuition without concepts are blind. This proverb is very much relevant to this manufacturing technology. So what is conceptual idea? A multiple conceptual idea generated in order to solve a problem, address a market need, or changing in the existing. What we are going to manufacture, first of all, we go for what is the market need, what people wants. If people want some new things, for innovative things, then we have to go for such manufacturing that will be suit to the people or suit to the public. The effective idea generation is not merely the result or outcome of creativity, but need to be perceived as a part of integrated analog thinking. Development of conceptual idea, a number of suitable ideas chosen or filtered. A number of ideas came in our mind, but out of this various conceptual idea, we choose the perfect idea which will be used for R&D and design in view of manufacturing any products. So it is said that think globally and act locally, as I told earlier also, signify creativity, invention, discovery, innovation, etc. We often forget the minor difference among these. So creativity is nothing but conceptual idea is the base of the creativity. Creativity is the conceptual idea. First we go for the conceptual idea, what conceptual idea is there, then we go for the creativity, then we go for the R&D, then we go for the design, and then for the manufacture. And finally we get the product. So creativity comes with the responsibility. Creativity is the key to finding inspiration of new engineering design solution within the constraint of ethnic engineering product practice. The scientific way of defining creativity is a continuous effort. So D. Bono in 1996 defined creativity as the creation of something that did not previously exist in its present state. Creation is creativity, or creation you can say, is nothing but the something that did not previously exist in its present state. That is called creativity. So creativity is the prime source of mind, which drives the mind continuously, keeping ultimate goal of creation, iterative thinking, distant vision, great idea, and inspiration. Thus, creativity is the capability to act, conceiving something unusual idea. So, creation of an unusual idea. This is the creativity, and this is the product development. So, with this creativity, first we have to think about creativity in our mind. Then we go for the vision, inspire, ideas, thinking, and mind. And from creativity to go for the product development. So from creativity to product development, we have to cross this R&D, design, and all conceptual idea. Then we go for the manufacture, and finally we go for the finished product. So management is skill for innovative manufacturing. So when we go for the innovative manufacturing, this is one tables. New need. What is the public needs? What is the public new needs? What is the society needs? Societal needs. So new need. What is the need? We go for the new need for society and the marketplace. What is the market? What is the market need? What the people wants? What is the what society wants? Then we go for the need of society and the marketplace. Then idea generation. Then we'll go for the idea generation, and then we go for the new technology. New technology. And then we go for the research and development, prototype production. Before manufacturing, we will go for prototype production in a small scale, and after that we go for the manufacturing. Then marketing and sales. After manufacturing, we go for the marketing and sales, and then we finally with the marketplace where our product has to be sell out. So this is the management skill for innovative manufacturing. So product development for creativity. Creativity first we have to be creative, and creativity has to be done. And with this creativity, all things are based on creativity, like discovery, invention, innovation, intellectual property right, that is processing, real training concept, tuning concept, and developing concept, conceptual idea, and that is the conceptual idea. Repeat training, it is not clear actually. When I kill this conceptual idea, I think. So, and what is discovery? People often confuse the in between discovery, invention, and innovation. Discovery is nothing but is the evaluation of human knowledge. In other words, a discovery is something that already exists at the time of discovery, but was previously not known. This is the difference between invention and discovery. Discovery means that Ohm's law, Ampere's law, any law which was existing in the world, which were existing in the world, but it was not known. That Ampere's law, Archimedes' law, Ohm's law, it was existing, already was there, but it was not known. It is called discovery. So this discovery, as far as from discovery, nothing will change apart from associated increase in knowledge. In this discovery, we increase our knowledge, enhance our knowledge. Discovery are therefore a very first expansion of natural law, or a law derived from a natural law. That is natural law, that is I was talking about. Natural law, that is by all law in physics and chemistry we study, that is the discovery. Discovery normally occurs without purpose or accidentally. Discovery normally occurs without purpose. Without any purpose, discovery occurs. And it occurs accidentally. Like Newton, he has seen that one apple was falling down from a tree. It was accident. It was accidentally he has seen Newton's Sir Isaac Newton. He has seen that, and from that very beginning, falling of the apples, he has discovered gravity. In addition to invention that need to systematic thinking and operating process, discovery still needs some testing in order to determine the feasibility thereof. So, Tim Berners-Lee created the World Wide Web, WWW. It has been discovered by this Tim Berners-Lee. Now come to the invention. The difference between discovery and invention. Invention means this instrument or this device is not existing in the world. It was not existing in the world. That is called invention. Invention is related with something that was not previously there. But in discovery, it was previously there. Law was previously there. That is why invention are creative achievement which allow for previous unknown solution and application in the area of technology. Invention usually overcome the three criteria. That is patentability, novelty, inventive steps, and commerciality. Out of this novelty, inventive steps, and commerciality, anything can be patented. Any new device can be patented. Any invention can be patented only when this device should have novelty, inventive steps, and this commerciality. Otherwise, it is not invention. Or if it is not invention, then it will be not patentability. It will not be patented. So, an invention is directed in line with a goal. The entrepreneur realized that instance that a technology product will become obsolete in a fixed month time. Like you see, the Kodak camera. Kodak camera has outdated and obsolete. It was not there. And previously it was a thin film camera was there, and we go to the dark room and then we developed this photograph. Now there is a digital camera. So this is the development, technological development. And this is called invention, or you can say innovation. So the invention process is then based on various research and testing intervention before the new or changed product is commercialized. Patents are therefore granted for invention. Patent is only granted for invention. If it is invention, then patent will be granted, otherwise it is not granted, which are new related to inventive activity and are commercially applicable. So necessity is the mother of invention, it is called by Plato. Plato has said that necessity is the mother of invention. When there is necessity, there will be invention. So Thomas Edison created an electric bulb. In the world, Thomas Edison, such a scientist, he has more than 1,000 patents, but he was known only for this electric light bulb. So 999 patents, nobody knows what are the patents, what are the patent subject, nobody knows. But Thomas Edison was only was known for electric lights. So I request all of you, faculty members and the students, go inventing the things, go patenting the things. Who knows who will be the Thomas Edison? By one patent or one invention, one can be a great scientist. Like this, Alexander Graham Bell created telephones. And now come to the innovation. We have discussed discovery, invention, and innovation. Innovation is essential to create more economic and social opportunity for many countries. If there is an invention and if you have something addition of the invention, then it is called innovation. But it should have social opportunity to add social needs for marketing or for commercialization. In a competitive global market, innovators must constantly innovate to create new solutions and invent new way of solving market problem. So market problem, first market research should be done before going for innovation. New idea may be creativity for human beings, but there is no innovation. But something gets implemented after invention and obtaining patent. Every invention is an innovation, but every innovation is not an invention. So this is a very important sentence. Every invention is an innovation, but every innovation is not an invention. It is not necessary that is an invention. So innovation can be incremental or radical. And innovation comes from the following. Any need in the public domain. If it is need in the public domain, then it will be innovation. High cost of product, commodities. If the cost is very high, then we go for the innovation. Audited version of the existing product. If the product has been audited, then we go for the this innovation. So like in TV, we can say LED TV, smart TV, AI TV. The need of the society, need of the market, when we are going for the innovations. And previous TV is getting audited. The product of the inventor of chemotherapy, pollen, reached 1854 and 1950 took 25 years to come into the existence. Similarly, this Rudolf Diesel, 1858 and 1913, had to wait 35 years before the diesel engine was commercialized. He has invented this. Rudolf Diesel has invented the diesel engine, and after 35 years, it was commercialized and came into the public domain. So innovation, there are some innovation technique. Innovation is always seen in an entrepreneur. Perspective. Innovation is a process by which that entrepreneur has the opportunity to make the idea become marketable. Entrepreneur combine creative idea and market opportunity and actively pursuing an entrepreneurship opportunity to creativity with a bunch of business. Origination of ideas is important, and also creative thinking may play a role in development. Innovation is combination of insight of a good idea of implementation. Essentially, the concept of innovation is from management perspective, begin from thoughts and end with the release of new product of service business. There's a new products come into the manufacturing process. So this one more innovation is called disruptive innovation. It is nothing but the term disruptive is misunderstood. That is, disruptive innovation is misunderstood. It cannot be understood. This is what is disruptive innovation. Many people think it is just new and different radical improvement. Instead, disruptive innovation changes industries because it changes the industry because it makes complicated and expensive process simple. Disruptive innovation is fast innovation that make complicated and expensive process simple. That is called disruptive process, disruptive innovations. Open them up to a wider audience. So now come to the revolution, industrial revolution, by which this manufacturing sector, with the help of manufacturing sector, we can revolutionize the total industrial sector. So nowadays we are talking about fourth industrial revolution, that is 4.0. Then people will know that what is 1.0, 2.0, 3.0, and now 4.0. Up till now, there are four industrial revolutions. First industrial revolution came with the advent of mechanized steam power and water power, like hydraulic power, our hydel power, thermal power plant, like that. This was the first industrial revolution. The second industrial revolution, it requires mass production assembly lines using electricity. The second revolution came when electricity came. And third industrial revolution came, it came with the electronics, IT system, and somewhat automation, which led to fourth industrial revolution. Now, we're going for the fourth industrial revolution. It is with the cyber physical system, like our 3D printing, our smart TV, smart marketing, and electronic media, like that. So evolution of manufacturing from industry 1 to 4, that is nothing but industry 1.0 automation and the use of steam and hydel power, electricity power, mass manufacturing assembly lines, automation, computer information technology system, and robotics. Robotics comes to industry 3, and industry 4, IoT, Internet of Things, machine learning, smart factory, and automated system. And you can add up another thing also. So industry 4 technology is nothing but, in general, industry 4 describes the growing trends towards automation, data changes in technology and processes within the manufacturing industry, include the Internet of Things. We will discuss this, Internet of Things, the industrial Internet of Things, cyber physical system, smart manufacturing, smart factory. This is smart manufacturing and smart factory, the same thing. In a smart factory, we go for the smart manufacture, the cloud computing, cognitive computing, and artificial intelligence. This artificial intelligence technique is the mother of all smart manufacture and a smart factory. Without artificial AI technique, we cannot go for the smart manufacture and the smart factories. So this is artificial intelligence technique nowadays we are talking about. This application of AI is in every field. Like you can see here, it is being surveillance, healthcare, medical system, agriculture, computer vision, IoT application, and smart city, education, learning, business, finance, social media, virtual reality assistant, intelligence system, robotic automation, autonomous vehicle, industries, entertainment and games, internet and search engine recommendation, travel and transport, cybersecurity and the intelligence, natural language process, and surveillance. So here we are talking about intelligence system, robotics, and automation. Automation and this industry. How to automate this industry, particularly the manufacturing industries, with this industry and intelligence system, robotics, and automation. So application of AI is a very important in all automations or smart manufacturing or smart factories. So in these four revolution 1.0, 2.0, 3.0, and 4.0, we can distribute here from here to here these four revolutions. You see, the first revolution, steam engine. This is a railway, And the second is revolution 2.0, telephone, automobile, and electricity is the second evolution. And third evolution is computer is came, and somehow to internet. Now this is the fourth revolution. 4.0 industrial revolution, artificial intelligence, energy storage, robotics, genomic sequencing, and blockchain technology. So this is a very, very beautiful graph. Economical activity. This is the economic activity. By 4.0, you can see the economic activities rising like anything. So area where robot and can be used in manufacturing, robotics, or you can say automation, where we can use this in manufacturing, that is material handling, welding, assembly, dispensing, or processing. Apart from these processing, manufacturing processes, in other processes we can use this like CNC machine, welding, or you can say finishing product, grinding, or any mechanical system. You can have this automation. So this is the material handling. These have been leaking, welders out, network. These are the description about the assembly and welding and all that. So what are the features of artificial intelligence for manufacturing industry? Feature means what benefit we are getting about this automation in manufacturing industries with the help of artificial intelligence. Automation can be possible only when there will be artificial intelligence in manufacturing industries. So what advantage we are getting with this automation? First advantage we are getting with customer satisfaction. With the systems of AI, the organization can provide proactive, streamlined, and personalized service inclined to improve their experience. Trust. There will be mutual trust between the party, with the customer and the manufacturer. Fully transparent system can increase customer loyalty in our system. And there is fairness. There will be fairness between the two people. Provide fairness to terminate the basic bias for the system as it is a significant need. And the last one is transparency, very much important. With digital transformation or digital automation in manufacturing industry, there will be transparency. Explainable AI offers a significant amount of transparency. AI system transparency facilitate understanding and trust in it. So now come to the intelligence system. Intelligence system is nothing but artificial intelligence system. Briefly, I can finish this intelligence system. The intelligence is nothing but function with high degree of autonomy. Intelligence system is in the autonomous, or you can say the automated vehicle, or you can say automated industries, or you can say the automation in the manufacturing industries or in industries. Without intelligence system, we cannot think of even the automation in manufacturing industries. So function with high degree of autonomy, robustly handle data and large amount of noises, rapidly process large amount of data in a massively parallel fashion, learn from the environment with minimal human intervention, evolves, become better adapted. So where this intelligence system came, how came into the in human mind? Nature influenced the scientific investigation. This artificial intelligence technique, we have taken this cognizance with the natures. Nature is influencing researcher in many ways. History shows the many scientific investigations were motivated by natural phenomena. Like with this word, we have artificially intelligent this aircraft. We have got the idea with these words, and with this word we make it into artificial intelligence, and we go for this our aircraft. Similarly, insects, we go for robotics movement. Similarly, ants, from these ants we learned and swarm bots have been prepared. Now from the fish we go for the ship, the horses, the horse cart, and the spider web, we go for the assisted material. And now the last one, which is very, very important, with this human being, we go for the robots. We got it artificial intelligence with the help of these human beings, with the human brains, and now we have made this robotics and robots. So artificial neural, this is optimization technique. This artificial intelligence technique. There is number of optimization techniques. This is one of the artificial neural network. Another one is physiology technique. Apart from this, there are other techniques also. So basic concept, all of you know, nothing new. Neural network, which is simplified model biological neural system, is massive parallel deep processing system made up of highly interacted neural computing element that have the ability to learn, thereby acquire knowledge and make it available for use. There are various learning mechanisms exist to enable the neural network acquire knowledge. The first one, training, learning process, and inferences, ability to solve the problem with the knowledge. The structure constituent of the human brain termed as neurons, neural network is used to learn patterns and relationship in data. So biological inspiration, some numbers, the human brain contain about, it must be known, 10 billion nerve cells. Each neuron is connected to other through 10,000 synapses. Properties of the brain, we can never think of the property of the brain. It can learn, reorganize itself from the experience. It adapts to the environment. It is robust and fault tolerance. So this is a model of a biological neuron. Here is a cell body. This is called nucleus, the synapses, and this is the axon and the dendrite. There are a number of these type of biological neuron in our human brain, by which we can have the robots. We go for the robot, and we have made the robot. So a neuron has branching input, that is called dendrite. This is called dendrites. Branching output, this is called axon. This is axon. The information circulates from the dendrite to the axon with the cell body, and this is called cell body. This type of figure, a number of this neuron in our human brains. This is one of them we have shown. So axon connect the dendrite via synapses. Synapses vary in strength. Synapses may be exactly or inhibitory. So this is a very typical neuron we have made. This is the input. Input we are giving here. Here we are giving input in our human brain, and this is the soma. This is the soma, and this is the axon. We are getting here output. So any complicated worldly system or non-linear system, if you want to get it output, we want the output from the non-linear input data. With this, we can easily get the output data with this artificial neural network on this neuron. So this is a very neural network controller for mining purpose. We have made this. So these are the various mining data, and I want mining data wherever I was working. That is such a sort. The various mining data, and this is the neuron. This is the first layer, the second layer, third layer, fourth layer, and the fourth layer, and we the output layer. We various data we have got the setting load which is required for my support parameter. So now come to the digital manufacturing. It is also called additive manufacturing. Additive manufacturing nothing but it is the layer by layer manufacturing. The good example is 3D printing for the additive manufacturing, which is an integrated multi-objective optimization problem underlying digital manufacturing. Recently evolved in the past decade. It is initially known as computer integrated manufacturing. That is called CIM, computer integrated manufacturing. The concept traditionally describes the application of suite of tools to facilitate the integration of product and process design. Broadly, the traditional understanding the digital manufacturing can be viewed as a part of change from cost-driven knowledge-based manufacturing. Knowledge-based manufacturing, there is nothing but the CIM, or you can say internet-based AI-based manufacturing. One such process innovation has received significant attention in additive manufacturing, that is called AM, also known as 3D printing. 3D printing is the best example for digital manufacturing. So digital manufacturing is nothing but this is a product design. Digital manufacture, information structure. This is a structure, it has been made. So this is a product design. First the product design. First we'll go for the product design. Before that we go for the conceptual idea or creativity that I have discussed earlier. Then we go for the product design. The product design, product planning, product engineering and design validation, then data transfer. Then we will go for the machine setup, manufacturing process, then product removal, post-processing, quality control, distribution, use phase, and end of life. And this is all together we go for the manufacturing process. Then we go for the marketing the products. So integrated multi-objective optimization problem is the manufacturing process Simply, integrated framework of the assessment of digital manufacturing. These are a picture of digital manufacturing. So, commercialization of the product. When we manufacture the product, we go for the commercialization. This is very simple. The first definition of the term enterprise was given in the Kanti Kalyan. Though I have previous also we have discussed. We all know that India, the European country, it has first position in the world for its population. Now our country has the first position in line of population. Our visionary Prime Minister has staged upon the manufacturing sector for product development. Economic growth of India solely depends upon innovation, new product development, and its successfully commercialization. But still, it is not taking the growth as it should be taken. So we are lagging behind in manufacturing, particularly in digital manufacturing, or in automation in manufacturing, or automated manufacturing. You can say it is an easy ability to people that enable them to begin new startup. When we go for the new startup, that means we go for the new manufacturing. Entrepreneurship is the process of creative initiative that is essential to the sustainability or economic development. Relationship between the creativity, innovation, and entrepreneurship. There is interrelationship between creativity, innovation, and entrepreneurship. Because barring these three terms, creativity, innovation, and entrepreneurship, we cannot think of good manufacturing or any smart manufacturing. Now, this is a commercialization of a product. This is a very simple photograph we have made. This is the invention. Here the invention, new idea, new product, new creativity where we invent it. Then we go, how we invent, the creativity should be there, motivation should be there, supporting organization should be there, and ideas should be there, and expertise should be there. These four things required to go for the invention. Then the supporting organization institute, they will support our organization or our institute like your IGIT, Sarang, will support this for this invention. Then we go for the collaboration industries and this collaboration. Then we will go for the develop products, resources. For develop product, we require resources and path towards products and business model. Now then come to the commercialization of the any products. So, complete journey of economic development is creativity, invention, entrepreneurship, commercialization, innovation, and economic growth. Economic growth inclusive of all these things. Like industrial growth, or you can say economic growth, only possible then only when then there will be creativity, invention, entrepreneurship, commercialization, and innovation. Without which we cannot think about any industrial growth or industrial economical growth. So finally, the conclusion is innovative engineers can play an important role in developing our country idea by flagship program of our country, that is Innovate in India, Make in India, Digital India, like this. Engineers can discover the new technology and new product process and contribute themselves for development of the nation in line to Atmanirbhar Bharat. That is the slogan of our Prime Minister. The complete journey has been shown from creativity to economic growth at all needed for any developing countries. So it is all about. Thank you. Any question from your side? Hello? Hello?
Hello.
Hello?
Hello. Hello, sir.
Hello? Hello, sir. Hello, ma'am.
Yes, sir. Yes, sir. Sir, your screen is not visible, sir.
Pardon? The screen is not visible?
Yes, sir. Screen is not visible.
Just now not visible, huh? Just now it is not visible?
Yes, yes. Now only, sir. Yes, sir.
Oh, okay. Just a minute. Is it visible?
Yes, sir.
Is it visible?
Yes, sir. Yes, sir. Yes, sir. Visible, sir. Hello, sir.
Hello.
Sir, sir, the participants can ask questions.
Yeah.
Yes, sir. Yes, sir. Okay. So participants, now you can ask if any doubt. You can ask. Interact with the speaker. Otherwise, you can chat. You can mention your question in the chat, participants. Yes.
Good evening, sir.
Good evening.
Sir, I'm Chandra Prakash Sharma, assistant professor from the Bhara University.
Okay.
Sir, I'm just ask a simple question to you. You can talk about the commercial of a product. So, sir, my question is, what are the legal protection are available for the eco-friendly mining technologies, sir?
Pardon, commercial, what are legal?
Yes, sir.
Oh, okay. When you are going for any product development and any new products,
Yes, sir.
before going to the market or going for to the mines,
Okay,
you
sir.
have to contact the DGMS
Okay, sir.
for this statutory approval. That is called Director General of Mine Safety at Dhanbad. So after getting any product, you should contact DGMS for approval. Then we'll go for the marketing or any use of this product.
Okay, sir. Thank you so much.
Okay. So Mr. Abra Mukhopadhyay, sir, has asked if invention is innovation, then why not innovation is invention?
Okay. That I'm telling, if invention is nothing but invention is defined as that device that is not existing in the world. Invention is the device that is not existing in the world. That is the you can say the diesel engine. Diesel engine was not there. Rudolf Diesel and invention diesel engine. Okay, and if diesel engine, if diesel engine in diesel engine nowadays diesel engine is working or nowadays it is being commercialized everywhere. If there is if we use some nut and bolt in this diesel engine, and then we get the more efficiency in diesel engine, that is called innovation. But the nut bolt is already invented. So innovation is not invention, and that is invention is should have the maybe some innovations. So there is difference between innovation and inventions. That is clear, sir?
Yes, sir. So any other question from participant side? Okay, I think no question. Okay, thank you so much, sir.
Okay, thank you,
It was really
thank
very
you all
informative
for. Okay.
session.
Okay.
One request. So all of you, please switch on your videos. We'll have a photo. Participants, please switch on your videos.
Excuse me, ma'am. It's
Yes.
my humble request to you. Please kindly share a PPT. PPT.
Yes, yes, sir.
Thank
So, sir, can you please share the PPT so that it will be useful for the participants?
Yes, yes, I can share you.
Okay, sir.
In your mail, I will share.
Yes, sir. Yes, sir. Thank you, sir. So, sir agreed to share his PPT, so we can send it through the WhatsApp.
Thank you so much, ma'am.
Okay. Thank you, sir. So, participant, please switch on your videos. We'll have a photo. Sir.
Yeah.
Yes, sir. Sudhir, sir, can you please switch on your videos? We'll have a photo with you.
Okay. I'm doing this.
Yes, sir.
Okay, is it okay?
Sir, yes, sir. Yes, sir. Thank you, sir. Okay, it's fine. Thank you.
Okay.
Thank you, all the
Thank you.
participants.
Thank you.
So, thank you so much, sir.
Thank you to you all for
Thank-
giving me this opportunity to join with you and to learn from you people, for you learned faculty members and students and research fellows and all project fellows. So I'll wish a great grand success of your institute, IGIT Sarang,
Thank
and
you,
all
sir.
faculty members. Go ahead with this smart manufacturing and digital manufacturing. Thank you.
Thank you, sir. Thank you. So, participants will meet again at 7:30. Okay. Thank you.
Okay. Thank you, ma'am.